Hi, my name is Mauruf Ali. I am finally a diploma mechanical engineering student of Government Polytechnic College Manjeri. First of all, I welcome our HOD Anup sir, our tutor Shukur sir, my guide Shajul Dinesh sir, my classmates, and our other teachers to my seminar presentation video. My seminar topic is sensor technology. So we are going to the presentation. These are the contents included in the PPT. First, we are going to the introduction for sensor technology. A sensor is a device that measures a physical quantity and converts it into a signal, which can be read by an observer or by an instrument. Next, what is a sensor? A sensor is a device that receives and responds to a signal. A sensor sensitivity indicates how much the sensor output changes when the measured quantity changes. Sensors are a new solution for measuring current and voltage in medium voltage power system. Objectives of sensor: reduce manpower, provide more safety, utilize maximum time, and increase productivity in industries. Basic components used in sensor network: microcontroller, transceiver, external memory, power source, and sensor. This is the flow diagram of sensor technology or sensor network. So there are two sensors and a transceiver, microcontroller, external memory, and a power source. So the sensors detecting the environmental changes and send us electrical signal to the microcontroller. Microcontroller responds to the signal. That response done by the transceiver. The external memory store the data. Power source gives the power for working the network. Next, voltage divider in sensor technology. The main components of the sensor is resistors. This is the basic connection of sensor. Sensors pinout types. There are two types pinouts: 3-pin sensor and a 2-pin sensor. 3-pin sensor. Sensors that have 3 pinouts by which one can connect them into any circuit or to the microcontroller. There is the current input and output and GND. Next, 2-pin sensor. Most sensors that have two pinouts. This type sensors needs to be connected to a resistor. There is a resistor must to connect. Sensors using area. Mostly the sensors using medical industries, automotives, industrial applications, aerospace and defense, and agricultural areas. Mostly using sensors. These are the sensors mostly using. We are discuss each one in detail. First, we are going to discuss temperature sensor. A temperature sensor is an electronic device that measures the temperature of its environment and converts the input data into electronic data to record, monitor, or signal temperature changes. Non-contact temperature sensors are usually infrared sensors. Temperature sensor using area: food processing area, environmental control, medical devices, chemical handling, and automotive under the hood monitoring. Types of temperature sensor. There are four types of temperature sensors: thermocouple, RTD or resistance temperature detector, thermistor, and semiconductor. First, we are going to discuss about thermocouple. The operation principle of the thermocouple is based on the filter effect. This is the working diagram of thermocouple. There are two types metals. The two metals joined together to form two different temperatures. So the first junction is measuring junction or hot junction. Next, the reference junction or cold junction. So the heat source in measuring junction. So the different temperatures produce a EMF. That EMF called filter EMF. Voltmeter read the EMF and send us electrical signal to the microcontroller. Next, resistance temperature detector or RTD. The RTD operates on the principle that the electrical resistance of a metal changes predictably in an essentially linear and repeatable manner with the change in temperature. This is the working diagram of RTD. So, this is the working diagram of RTD. The detector detects the environmental changes in temperature. So, the temperature increases, the resistance also increases. So, the resistance difference acts on the voltage or current flowing through these wires. So, this measured the microcontroller. Okay, next we are going to discuss about thermistor. A thermistor is a resistance thermometer or a resistor whose resistance depends on the temperature. A PTC thermistor works a little differently. This type of thermistor is generally used as a fuse. This is the working diagram of thermistor. There is using the NTC thermistor. This is the temperature high, resistance low. But PTC is temperature high, that time resistance also high. So this is used as a fuse in a safety system. This is used for a safety. The system have a particular temperature. It's raised above the temperature, the fuse will cut and provide safety for the system. Next we are going to the semiconductor. Most silicon particles detector works in principle by doping narrow silicon strips to turn them into diodes, which are the reverse bias. The charged particles pass through these strips. They cause small ionization currents that can be detected and measured. The semiconductor working diagram. This is the diode. The temperature increases. There is produce holes and the voltage or current passing through these diodes. There is a small ionization current produced. This can be read and measured and send the microcontroller in response to the signal. Next we are going to discuss about pressure sensor. A pressure sensor works by converting pressure into an analog electrical signal. The demand for pressure measuring instruments increased during the steam age. Nowadays we measure pressure electronically using pressure transducer and pressure switches. Pressure sensor using area, altimeter, barometers, sensing printed ink levels, airflow rate in equipments, IT center or computer cooling systems, semiconductor process equipments, and a laser measurement. Types of pressure sensor. There is a potentiometric pressure sensor, inductive pressure sensor, capacitive pressure sensor, piezoelectric pressure sensor, strain gauge pressure sensor, and a variable reluctance pressure sensor. We will discuss each one in detail. This is first we are going to discuss about potentiometric pressure sensor. The principle of the potentiometric pressure measurement is based on the change in resistance of a potentiometer. So this is the working diagram of potentiometric pressure sensor. So the pressurized fluid is the pressurized fluid. This pressure applied through this and it acts on the helical burden tube. Helical burden tube connected to a wiper arm. Wiper arm connected to the potentiometric element. So the pressure difference acts on the helical burden tube and it goes to the potentiometric element. So the resistance will vary with the pressure difference and the send us electrical signal to the microcontroller. Next we are going to discuss about inductive pressure sensor. An inductive pressure transducer uses the principle of inductance to convert the flexing of a diaphragm into the linear movement of a ferromagnetic core. This is the working diagram of inductive pressure sensor work. So there is a magnetic mobile core and coil leads and insulated coil form coil, spring, bellow, pressure unit. So the pressure act on the bellow, the core displacer. So there is a current, AC current. So the movement of the core differs the secondary coil current, and it is measured and sent as electrical signal to the microcontroller. And we are going to discuss about capacitive pressure sensor. The capacitive transducer works on the principle of variable capacitance. The capacitance of the capacitive transducer changes because of many reasons, like overlapping of plates, change in distance between the plates, and a dielectric constant. The capacitive transducer contains two parallel metal plates. This is the working diagram of a capacitive pressure sensor. So the pressure and act on the pressure bellows. So the pressure difference act on also in the diaphragm. So this displacement of the diaphragm changes the capacitive press current and sends the electrical signal to the microcontroller. Next we are going to discuss about piezoelectric pressure sensor. Working principle is a force is applied to a piezoelectric material and electrical charge is generated across the faces of the crystal. This is the working diagram of piezoelectric pressure sensor. The pressure enters through this and act on the crystal. The crystal is a piezoelectric material. So the pressure increases, the voltage in crystal is increases. So that voltage read by an microcontroller and send us and a response to the signal. Next, the strain gauge pressure sensor. A strain gauge is a sensor whose resistance varies with the applied force. It converts the pressure into a change in electrical resistance, which can then be measured. When external forces are applied to a stationary object, stress and strain are the result. This is the working diagram of strain gauge pressure sensor. So the applied pressure, the pressure act on the diaphragm, and the strain gauge detect read the pressure within the form of strain, and this is the strain gauge connected to a voltmeter, and there is the pressure difference change into electrical signal and send as electrical signal to the microcontroller. Next, variable reluctance pressure sensor. The variable reluctance sensor is an strain base wherein a magnetic circuit is formed and the parameter input causes mechanical deflection of the spring member as a function of pressure. This is the working diagram of variable reluctance pressure sensor. So the pressurized fluid flow through these pipe lanes. The pressure act on the central diaphragm. There is a magnetic field. So the deflection of the diaphragm changes the magnetic field oscillation, and this varies the voltage or current in the output. So this sends us electrical signal to the microcontroller. Next we are going to discuss about proximity sensor. A proximity sensor is a sensor able to detect the presence of nearby objects without any physical contact. A, a proximity sensor often emits an electromagnetic field or a beam of electromagnetic radiations and looks for the change in field or return signal. Proximity sensor using areas: phones, recycle plants, self-driving cars, and aircraft systems, assembly lines, and machines. Types of proximity sensor: inductive proximity sensor, optical proximity sensor, capacitive proximity sensor, magnetic proximity sensor, and ultrasonic proximity sensor. We are discuss about inductive proximity sensor. Inductive proximity sensor are used for non-contact detection of metallic objects. This is the working diagram of inductive proximity sensor. So the oscillator circuit produce a magnetic field. The metallic objects enters the magnetic field area region. So there is a amplitude change, and that amplitude that so that difference detected and measured and sent as electrical signal to the microcontroller. Capacity proximity sensor. The capacity proximity sensor is one plate of a capacitor. The target serves as the other plate. The air gap between the sensor and the target functions as the dielectrics. This is the working diagram of capacity proximity sensor. So, there's internal capacitor plate and efficiently capacitor plate in target, the oscillator, and the current sensor. So, it is used in metallic and non-metallic objects also, detecting the proximity presence. The oscillator produces a electrostatic field. So the displacement of or there is a air gap, there is a electric. So the objects comes to this region. There is a amplitude changes, and it affect the voltage, and the difference send us electrical signal to the microcontroller. Next we are going to discuss about magnetic proximity sensor. Magnetic proximity sensors are actuated by the presence of a permanent magnet. The presence of a magnetic field makes the thin plates flex and touch each other, causing electrical contact. The plate surface has been treated with a special material particularly suitable for low current or high inductive circuits. This is the working diagram of magnetic proximity sensor. So this is only able to detect the presence of metallic objects. So there is a permanent magnet. So the magnetic properties is helps to detect the presence of the metallic objects. Next we are going to discuss about ultrasonic proximity sensor. Ultrasonic proximity sensor emits and receives sound waves. They carry signal is a high frequency inaudible sound wave. They detect the presence of the target objects in one of two configurations. When the target enters the sensing range of its device, the ultrasonic waves are reflected back to the sensor. So this is the working diagram of ultrasonic proximity sensor. So the sender or receiver send the ultrasonic waves, and the objects comes to the region of the ultrasonic wave, ultrasonic proximity sensor region. So the wave reflected go touch the objects and reflected to the receiver. So it is detected the presence of the objects. Next we are going to discuss about accelerometer. The basic underlying working principle of an accelerometer such as such as a dumped mass on a spring. When acceleration is experienced by this device, the mass gets displaced till the spring can easily move the mass with the same rate equal to the acceleration in descent. This is the working diagram of accelerometer. So, the acceleration act on the device. The mass also displaced with respect to the acceleration. So, the seismic mass displaced according to the acceleration increases. So, the piezoelectric element or spring changes the electrical signal to the electric signal, varies the electrical signal and send us electrical signal to the microcontroller. Okay. Next, accelerometer using area. Measuring vibration on cars, machines, buildings, process control systems and safety installations. Next we are going to discuss about gyroscope sensor. Vibration gyrosensors sense angular velocity from the Coriolis force applied to a vibrating object. When the gyro is rotated, the Coriolis force acts on the drive arms, producing vertical vibration. This is the working diagram of gyroscope sensor. The vibration detecting the drive member and the state member. So there is a Coriolis force acts and the sensing arm detects the vibration or the movement of the drive arm and send us electrical signal to the microcontroller. Gyroscope sensor using area. Car navigation systems, electronic stability control systems of vehicles, motion sensing for mobile games, camera shake detection system in digital cameras, radio controlled helicopters, robotic systems and etc. Next we are going to discuss about infrared sensor. An infrared sensor emits or detect the infrared radiation to sense its surroundings. The basic concept of an infrared sensor, which is used as obstacle detector, is to transmit an infrared signal. This infrared signal bounces from the surface of an object and the signal is received at the infrared receiver. This is the working diagram of infrared sensor. So the IR transmitter transmit the infrared waves and in the infrared sensor have a region that the object comes to this region, the waves bounce to the object and is reflected to the IR receiver. So the presence of the object is detected. Infrared sensor using areas, security alarms and automatic lighting applications. And we are going to discuss about optical sensor. These have a same principle or same procedure of IR sensor. This is the working diagram of optical sensor. There is also a transmitter and a receiver. So there is a light producer, the light transmitter. So the optical sensor have a region. The target enters the region. The light is bounces the target and reflected to the light sensor, and it can be detected the presence of the target. The optical sensor using areas, computers, copy machines, zeros, light fixtures, alarm systems, synchros for photographic flashes, and systems of object detection. Next we are going to discuss about gas sensor. A gas sensor is a device which detects the presence or concentration of gases in atmosphere. Based on the concentration of the gas, the sensor produces a corresponding potential difference by changing the resistance of the material inside the sensor, which can be measured as a output voltage. This is the working diagram of gas sensor. So the concentration the concentration of the gas, they changes the resistance in the inside the sensor. So this is a sensor changes the current in the voltage or current in the sensor, and it is detected and measured. Types. There are several types of gas sensor: metal oxide based gas sensor, optical gas sensor, electrochemical gas sensor, capacitance based gas sensor, calorimetric gas sensor, acoustic based gas sensor. Gas sensor using area: industrial plants, refineries, pharmaceutical manufacturing, fumigation facilities, paper pulp mills, aircraft and shipbuilding facilities, and hazmat operations, etc. Next, we are going to discuss about smoke sensor. The ionization types smoke alarms have a small amount of radioactive material between two electrically charged plates, which ions the air and causes current to flow between the plates. When smoke enters the chamber, it distributes it uh, or uh, sorry it disturbs the flow of ions, thus reducing the flow of current and activating the alarm. This is the working diagram of smoke sensor. So the smoke is produced. The smoke enters the sensor, enters the smoke to the sensor. There is two plates. The there is a ionization flow, ions flow. So the smoke disturb the flow of ions that can detected and measured, and send us to the microcontroller and activating the alarm. The smoke sensor using areas: industrial area, home, commercial area, and alarm systems. Next, this is my conclusion. Sensor technology systems can provide improved maintenance, safety, time saving, and cash saving in our life and industry. Sensors are connected to a computer. That computer gets signals from the sensor, and the computer orders to the transceiver or actuator by the analysis of this signal from the sensor. The sensor technology have an important role in our daily life. These are my references. Thank you for watching my presentation video. If any questions, ask me. Thank you.